It's really important to have some kind of a communication between the various components of an application. Specifically, when we're talking about microservices and a container based microservices approach, when we are developing modern applications, we need to have some kind of a communication that will tie those components and make them work together. We're talking about networking. AKS networking will allow the applications to communicate with each other so that the Kubernetes nodes are tied up to a virtual network so that some kind of an inbound and outbound connectivity for the pods can be established. Always remember that inside the node you have the pod, and then inside the pod you got your container running the application. That's the sequence. In the previous lesson, we did speak about kube proxy, right? So the kube proxy component runs on every node, and this is responsible to provide all the networking features that Kubernetes services needs. There are various concepts that we have inside the networking of your Azure Kubernetes services. So we've got to talk about services, Azure virtual networks, ingress controllers, and network policies. Let's talk about services first. So let's say you've built an application on Kubernetes containers in Azure, okay? Now you would like to expose that on some port onto the internet or maybe on the intranet, right? So this is done with the help of the first component called as services. Services will logically group the pods so that you can allow direct access via an IP address or a DNS name on a specific port. So remember, when you'd like to expose your application on a particular IP address externally or internally on a specific port, you would need services. Okay. For a larger application, you may also need a load balancer. You may need to configure complex application routing. Now, this is achieved with the help of ingress controllers. And if you would like to have some kind of a security and filtering of the network traffic for the pods, this is possible with the help of Kubernetes network policies. That's just a high level view of what each of these components mean. But as we drill down further into other sections and as and when we do the labs, you will understand them better and you will be able to connect all of these dots together. At this point, these services and these new terminologies may be overwhelming for you, but stay connected as we do and progress through the classes, you will understand them better. Let's talk about services a little bit. Every pod is listening on its own port number, right? So let's say you got multiple pods, pod 1, pod 2, and pod 3, and is listening on a particular port, let's say port number 80. And all these pods are running on a particular node, right? Or you also call it as a cluster node. So what we're essentially doing here is we are creating an internal IP address for use within the AKS cluster. This is good for internal applications only. So if you'd like to route your internal traffic within the Kubernetes cluster between the cluster nodes, you need the cluster IP. Every node has a port, and that is called as a node port. It's important to create a port mapping on the underlying node. So this will allow the applications to be accessed directly with the node IP address and its port. So by now we have two things, the IP address of the cluster node and the node port as well. If your application becomes bigger, becomes complex, and you would like to distribute the load, what you need is a load balancer. The load balancer will distribute the load between the cluster nodes. So you create an Azure load balancer, and this can either have an external IP address or an internal private IP address, depending on how you want to configure. The backend pool of the load balancer will be the cluster nodes or the Kubernetes nodes. You can have all kinds of load balancing rules written on the load balancer so that the incoming traffic can reach the appropriate application on the desired port. The load balancer can be exposed externally or can be routed just internally. It's important to have a specific DNS entry so that the application can be accessed through a name easily. And like I said earlier, the IP address of the load balancer can be dynamically assigned or even use a static IP address. When you use an internal load balancer, it will always and only have a static IP address. But when a load balancer is an external load balancer, it will have an external IP address or a public IP address.